Firstly, contact the Ohio Electrical Board to request a search of their records for your apprenticeship and journeyman credentials. Secondly, reach out to the local electrical union in Ohio to inquire if they have any records of your membership or work experience. Thirdly, check with the Ohio Department of Labor's Division of Industrial Compliance to see if they have any records of your electrical work. MSHA regulations do not directly qualify you for a journeyman electrician license. However, your experience in the mining industry, especially in electrical maintenance and troubleshooting, may be valuable to potential employers. If you can document your Ohio journeyman credentials, you may be able to apply for a reciprocal journeyman license in Montana. You can take the Montana Journeyman Electrician examination without being an apprentice, but you will need to meet certain experience requirements. If you have extensive experience in the electrical field, but cannot document it, you may be able to provide alternative forms of verification such as affidavits from supervisors or co-workers, logs or records of electrical work performed, and training certificates or continuing education completions. Contact the Montana Board of Electrical Administrators, or BOA, for specific requirements and guidance. Seek assistance from a licensed electrician in Montana to help you document your experience and prepare for the examination. Consider taking refresher courses or workshops to enhance your electrical knowledge and skills. Be prepared to undergo a background check and pay a licensing fee. When trying to get your electrician license, documenting your past experience is essential. If you worked in Ohio, try to find any records of your training or work. Contact the Ohio Electrical Board, the local electrical union, and the Ohio Department of Labor's Division of Industrial Compliance. Each of these organizations might have information that could help you prove your experience. Even though your work in the mining industry under MSHA regulations doesn't automatically qualify you for a journeyman electrician license, it's still valuable. The skills you've gained in electrical maintenance and troubleshooting can impress potential employers. In Montana, there are several ways to get your journeyman electrician license. If you can prove you have a journeyman license from Ohio, you might be able to get a reciprocal license in Montana. This means Montana recognizes your Ohio license. If you can't get a reciprocal license, you can still take the Montana Journeyman Electrician examination. However, you'll need to meet certain experience requirements to be eligible to take the test. If you have a lot of experience in the electrical field but can't document it through traditional means, there are alternative ways to verify your experience. You can provide affidavits from supervisors or coworkers, logs or records of the electrical work you've done, and training certificates or continuing education completions. To get clear information and advice, contact the Montana Board of Electrical Administrators, or BOA. They can tell you exactly what you need to do to get your license. It's also a good idea to find a licensed electrician in Montana who can help you document your experience and prepare for the licensing exam. If you want to improve your electrical knowledge and skills, consider taking refresher courses or workshops. This can help you feel more confident when you take the exam. Keep in mind that you'll need to pass a background check and pay a licensing fee to get your journeyman electrician license in Montana. Securing your electrician's license in Montana involves navigating various pathways, and your previous experience, particularly within the mining sector, holds significance. Let's delve into the specifics. The Montana Board of Electrical Administrators, or BOER, serves as the primary authority for all electrician licensing matters within the state. Engaging with them directly is paramount to obtain accurate and up-to-date information regarding requirements, procedures, and any potential waivers or accommodations applicable to your situation. Your extensive background as an in-house electrician for a mining company might be considered as relevant experience towards fulfilling the requirements for a journeyman electrician license. While MSHA regulations may not directly translate into licensing eligibility, the practical skills and knowledge acquired in that role, particularly in electrical maintenance, troubleshooting, and adherence to safety protocols, can be compelling evidence of your competency. It is essential to meticulously document your work history, detailing the scope and nature of your responsibilities, the types of electrical systems you've worked on, and any specific projects or accomplishments that showcase your expertise. This documentation will serve as a crucial component of your application to the BOA. Furthermore, explore the possibility of alternative experience verification methods. Since formal documentation from your higher apprenticeship is unavailable, consider gathering affidavits from former supervisors, co-workers, or clients who can attest to your skills and experience. These affidavits should be notarized and include specific details about your work ethic, technical abilities, and overall competence as an electrician. Another avenue to pursue is the potential for reciprocal licensing agreements between Montana and other states, including Ohio. If you can obtain documentation of your Ohio experience, even if it's not a formal license, it might be sufficient to qualify for reciprocity in Montana. Contact the BOA to inquire about the specific requirements for reciprocal licensing and whether your Ohio experience aligns with those criteria. In addition to documenting your work history and exploring alternative verification methods, consider enrolling in continuing education courses or workshops related to electrical codes, safety regulations, and industry best practices. These courses not only enhance your knowledge and skills, but also demonstrate your commitment to professional development, which can be a positive factor in your licensing application. As you prepare your application, be prepared to undergo a thorough review of your background, including criminal history checks and verification of any certifications or training credentials you possess. Honesty and transparency are paramount throughout the process, as any misrepresentations or omissions can jeopardize your chances of obtaining a license. The Montana Board of Electrical Administrators, or BOER, is the ultimate authority on licensing requirements. Contact them directly to discuss your specific situation and receive tailored guidance. While onshore regulations may not directly equate to a journeyman's license, your mining experience provides valuable hands-on skills. Document everything. Compile a detailed record of your mining work. Focus on electrical tasks, systems maintained, and problem-solving scenarios. This demonstrates your practical knowledge. Seek affidavits. Obtain notarized statements from supervisors or colleagues who can vouch for your electrical abilities and experience gained in the mining environment. Check for reciprocity. If you can find any documentation from your Ohio experience, explore if Montana has reciprocity agreements with Ohio. This could streamline the licensing process. Consider continuing education. Enroll in relevant electrical courses or workshops. This enhances your skills and shows your dedication to the profession. Be prepared for scrutiny. The BOA will likely conduct a thorough background check. Ensure all information provided is accurate and honest. Don't underestimate your mining experience. Highlight the electrical skills gained and relate them to standard electrician practices. Persistence is key. The licensing process can be complex. Don't get discouraged. Stay proactive and seek assistance when needed. Consider an electrician mentor. A local electrician can guide you through the Montana-specific codes and regulations. It can also provide valuable advice and support. Thoroughly review the Montana Electrical Code. Familiarize yourself with the specific requirements and regulations in the state. This will demonstrate your commitment to safe and compliant electrical work. If needed, seek legal advice. An attorney specializing in professional licensing can help you navigate complex legal issues. Remember that your unique background could be an asset. Your mining experience offers a practical perspective that sets you apart. Embrace your skills and highlight them throughout the licensing process. Explore all avenues, including documentation of Ohio experience, alternative verification methods, and continuing education to build a strong case for your eligibility. Stay informed, persistent, and proactive throughout the licensing process. Your dedication and experience will ultimately contribute to your success in obtaining your Montana Journeyman Electrician license. Understanding electrical principles is key to successfully navigating the electrician licensing process and performing electrical work safely and effectively. Electricity is the flow of electric charge through a conductor. This flow is driven by a voltage difference similar to how water flows from a higher elevation to a lower elevation. Voltage, measured in volts, is the electrical potential difference between 2 points. It represents the force that pushes the electric charge through a circuit. Current, measured in amps, is the rate of flow of electric charge. It indicates the amount of charge passing a given point in a circuit per unit of time. Resistance, measured in ohms, is the opposition to the flow of electric charge. It restricts the amount of current that can flow through a circuit for a given voltage. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage equals current multiplied by resistance, or volts equals amps times ohms. This fundamental law is essential for understanding and analyzing electrical circuits. Power, measured in watts, is the rate at which electrical energy is transferred or consumed. It is calculated by multiplying voltage by current, or watts equals volts times amps. Electrical circuits can be classified as either series or parallel. In a series circuit, components are connected end-to-end, forming a single path for current flow. The current is the same through all components in a series circuit, while the voltage is divided among the components. In a parallel circuit, components are connected side by side, providing multiple paths for current flow. The voltage is the same across all components in a parallel circuit, while the current is divided among the components. Electrical safety is of paramount importance when working with electricity. Always follow safety precautions to prevent electric shock, burns, and other hazards. Before working on any electrical circuit, ensure that the power is turned off at the source. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on live circuits unless absolutely necessary, and always use properly insulated tools. Grounding is a critical safety measure that provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electric shock. All electrical systems should be properly grounded to ensure safety. Circuit breakers and fuses are overcurrent protection devices that are designed to interrupt the flow of current in a circuit when it exceeds a safe level. Circuit breakers can be reset after tripping, while fuses must be replaced. These devices protect electrical systems from damage caused by overloads and short circuits. Electrical codes, such as the National Electrical Code, or NEC, provide comprehensive standards for the safe installation and maintenance of electrical systems. These codes specify requirements for wiring methods, conductor sizes, overcurrent protection, grounding, and other aspects of electrical work. Familiarity with the NEC is essential for all electricians. Wiring methods refer to the techniques and materials used to install electrical wiring. Common wiring methods include conduit, cable, and surface raceways. Each wiring method has specific applications and requirements based on the type of occupancy, environmental conditions, and other factors. Conductor sizing is the process of selecting the appropriate size of wire for a given electrical circuit. The size of the conductor must be adequate to carry the expected current without overheating. Conductor sizing is determined by factors such as the ampacity of the conductor, the ambient temperature, and the length of the circuit. Electrical boxes are enclosures used to house electrical connections and devices, such as switches, receptacles, and splices. Electrical boxes must be properly sized and installed to provide adequate protection for the wiring and devices. Electrical drawings are used to represent electrical systems and components in a graphical format. These drawings provide detailed information about the layout of circuits, the location of devices, and the wiring connections. Understanding electrical drawings is essential for electricians to install and troubleshoot electrical systems. The electrical testing and troubleshooting involve the use of instruments and techniques to diagnose and repair electrical problems. Common testing instruments include multimeters, clamp-on ammeters, and voltage testers. Troubleshooting techniques include visual inspection, voltage testing, and continuity testing. The Montana German Electrician examination assesses your knowledge and skills in various areas of electrical work. These areas include electrical theory, the National Electrical Code, wiring methods, conductor sizing, overcurrent protection, grounding, electrical boxes, electrical drawings, and electrical testing and troubleshooting. To prepare for the examination, study the NEC, review electrical theory concepts, practice solving electrical problems and take practice exams. Success in obtaining your Montana Journeyman Electrician license depends on your ability to demonstrate your knowledge, skills, and experience in the electrical field. By documenting your work history, seeking alternative verification methods, pursuing continuing education, and preparing thoroughly for the examination, you can increase your chances of achieving your licensing goals. When dealing with alternating current, or AC, circuits, it's important to understand concepts like impedance, reactance, and power factor. Alternating current is the type of electricity commonly used in homes and businesses. It periodically reverses direction, unlike direct current, or DC, which flows in one direction only. Impedance is the total opposition to current flow in an AC circuit. It includes resistance, which opposes current flow in both AC and DC circuits, and reactance, which is the opposition to current flow due to capacitance and inductance. Reactance is the opposition to current flow caused by capacitors and inductors in AC circuits. Capacitive reactance decreases as the frequency of the AC signal increases, while inductive reactance increases as the frequency increases. Power factor is the ratio of real power to apparent power in an AC circuit. It indicates how efficiently electrical power is being used. A power factor of 1 indicates that all of the power is being used effectively, while a power factor less than 1 indicates that some of the power is being wasted. 3-phase power is commonly used in industrial and commercial applications. It consists of 3 AC voltages that are 120 electrical degrees apart. 3-phase power systems are more efficient than single-phase power systems and can deliver more power for a given conductor size. Transformers are used to step up or step down voltage levels in AC circuits. Step-up transformers increase the voltage, while step-down transformers decrease the voltage. Transformers are essential for transmitting electrical power over long distances and for adapting voltage levels to different applications. Motors are used to convert electrical energy into mechanical energy. Electric motors are used in a wide variety of applications, from powering household appliances to driving industrial machinery. Understanding the principles of motor operation and control is essential for electricians. Motor control circuits are used to start, stop, and control the speed and direction of electric motors. These circuits can be simple or complex, depending on the application. Common motor control components include starters, contactors, and relays. Grounding and bonding are critical safety measures in electrical systems. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electric shock. Bonding connects all metal parts of an electrical system together to create a low impedance path for fault current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level. Arc flash is a dangerous electrical hazard that can occur when a high voltage arc forms between conductors or between a conductor and ground. Arc flash events can cause severe burns, injuries, and even death. Arc flash hazard analysis is used to determine the potential arc flash hazards in an electrical system. This analysis involves calculating the incident energy, the arc flash boundary, and the personal protective equipment, or PPE, required to protect workers from arc flash hazards. Electrical safety training is essential for all electricians. This training should cover topics such as electrical hazards, safety procedures, grounding and bonding, overcurrent protection, and arc flash safety. Regular safety meetings and job briefings can help to reinforce safety practices and prevent accidents. The National Electrical Code, or NEC, provides comprehensive standards for the safe installation and maintenance of electrical systems. It is updated every 3 years to reflect changes in technology and industry best practices. The NEC is a complex and comprehensive document, and it is essential for electricians to be familiar with its requirements. The NEC covers a wide range of topics, including wiring methods, conductor sizing, overcurrent protection, grounding, bonding, electrical boxes, electrical drawings, and electrical testing and troubleshooting. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for a particular aspect of electrical work. The NEC also includes tables and examples to help electricians understand and apply the code requirements. The NEC is not a design manual, but it provides minimum requirements for the safe installation of electrical systems. It is the responsibility of the electrician to ensure that the electrical system is installed in accordance with the NEC and other applicable codes and standards. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical systems are installed in accordance with the NEC and other applicable codes and standards. Electrical inspections are typically required for new construction, renovations, and additions to existing buildings. The electrical inspector will review the electrical drawings, inspect the electrical installation, and verify that it meets the code requirements. If the electrical installation does not meet the code requirements, the electrical inspector will issue a correction notice, which must be addressed before the electrical system can be energized. Electrical permits are required for most electrical work. The electrical permit is a legal document that authorizes the electrical work to be performed. The electrical permit application must include detailed information about the scope of the electrical work, the location of the electrical work, and the name of the licensed electrician who will be performing the electrical work. The electrical permit fee is typically based on the cost of the electrical work. Electrical codes and standards are constantly evolving to reflect changes in technology and industry best practices. It is important for electricians to stay up to date on the latest codes and standards to ensure that they are performing electrical work safely and effectively. There are many resources available to help electricians stay up to date on the latest codes and standards, including continuing education courses, industry publications, and online resources. By continuously learning and improving their skills, electricians can provide safe and reliable electrical services to their customers.